Hello, welcome to a bit of game dev. In this video, I'll show you how you can create this Earth Slam effect. The effect has three main components: the slam particle, the crack in the ground, and the rock. Let's start with the crack. Open up your 3D software, I'm using Maya, and create a simple plane. Then divide the plane in two along the forward direction. Now set the plane's pivot to be at the center top, and then align it to be at the world center. Now extrude the forward edges to be exactly 1 square in length. Make sure you extrude in the forward direction, in my case that's the downward direction, and set the last edge to be exactly at the center so it matches with the first edge. Now select all the middle edges and pull them down. This will give us a nice crack shape. Lastly, we want to harden all the normals. Now duplicate the shape 5 times, and going from last to first, scale each of the outside vertices to the center. We connect the 2 different pairs of vertices for each shape, so we have the 5 different variations. Now select the shapes from last to first, remember the order is important, and let's create a blend shape. In the top menu, go to Deform and select Blend Shape. Now open the Windows Animation Editor and then Shape Editor. These scales represent our blend shapes, and let's see how they work. Each of the scales deforms our mesh to one of the duplicated meshes. We will use this later to animate our crack opening. Now, when exporting, in Maya, select the FBX export, and then in the menu on the right, find Deformed Models, select Deformed Models, and select the blend shapes. Now export our model to Unity. In Unity, drag our model to the scene, and on the model, we can see the component Skin Mesh Renderer that has all our blend shapes. Now we need to make it so we can see our shape below the ground. Create a regular unlit shader and open the code. Now write this simple code. This is a basic depth mask. Make sure that in the tags we set the key to geometry -1. This shader will enable us to mask out the ground where our crack should be. Now create a material for our crack and a material for our depth mask. For the mask, select the mask shader. For our mask object, duplicate our crack and flatten it in the y-axis. This is because we want to mask out the flat ground. But we still need blend shapes so we can close and open the mask. Position our mask slightly above the ground and lower our crack object below it. We still can't see the crack object. That's because we need to go in the crack material and set the priority to -2, so it's rendered before the depth mask. Now we can see our model displaying correctly. Since we need to control the blend shapes of the mask and the model together, we'll create a simple script. In the script, the length variable represents how long our object is. In our case it's 4, since when modeling the object, we extruded the edges to exactly 1 square. Next, the blend shape count is how many blend shapes there are, and then we have the references for the crack and the crack mask. Next we have the 2 functions, one to get the blend shape and one to set it. I inverted the values to 100 minus value, because the blend shape is open when the value is 0 and closed when the value is 100. Now assign the script to our crack object, and we can see that our length is exactly 4 squares. Assign the values to the script and assign the references. And finally create a prefab. Next we need to create a script that controls our effect. It will control the opening and closing of the crack as well as the length. In the script, create a variable crack prefab so we can instantiate it, the open value so we can control how far we open it, the speed to control how fast we open our crack, and the range to control how far the crack is. Now create a coroutine called crackOpen, and first round our range to an int, because our crack can only extend exactly 1 square. Now create a start point vector and set it to the transform position. Next create a for loop that will increment by our crack prefab length. This will instantiate all the cracks we need to fill our range. When we instantiate the crack, set its transform position to the start point and set its transform forward to the transform forward of our parent object. Next, modify our start point by moving it forward exactly the crack prefab length. This will make it so our cracks seamlessly connect to one another. Finally, go through all the blend shapes of our crack and set it to 0, because we want our crack to instantiate closed. But for now, comment this part out so we can test if our positioning is correct. And in the update, let's call our coroutine by some key press. Back in the editor, create a new object and assign our crack control script. Assign the crack prefab, set the open value to 100, the speed to 1 and the range to 5. Now in the play mode, we can see we instantiated 2 cracks. This is because our range is greater than 4. If we set it to 4, we'll instantiate only 1 crack. Back in the script, let's refactor it a little bit. Create a new function called open, copy the start coroutine command from the update function to the open function, and create a new variable called container, and set the cracks to instantiate as a child of that container. And destroy every child of the container. That's so we can replay the effect without manually destroying all instantiated objects. Finally, call the open function in the update. Next, create a list variable called cracks. That's because we need to keep a reference of all the cracks we instantiated, so we can open and close them. Initialize the list, then add all the cracks to it. Next, we want to animate the crack's opening. To do that, loop through all the blend shapes of each crack, and then lerp its blend shape to the open value. Next, increment the lerp by our time.delta_time multiplied by speed, and then yield return null. Finally, when the while loop finishes, set the blend shape to exactly the open value. In the editor, create a child container object and assign it to our script, and press play. We can see that the part where the 2 cracks connect isn't animating quite right. This is because we want to animate the last and the first blend shape of each crack together instead of separately. We also want our first and the last blend shape to be closed. And we also want to correct our range by closing the unnecessary parts of the crack. First, let's check if we're animating the last blend shape of the crack, and is there another crack in front of it. If there is, animate the first blend shape of the next crack. Also, in the for loop, skip the first blend shape, because we want our beginning of the crack to be closed, and the first blend shape of each next crack is animated by the last blend shape of the previous crack. We can see that we fixed our first blend shape to be closed and the seam between the cracks to animate correctly, but we still need to fix the range. In our script, add the range index, so we know how far we animated. Then if our range index is equal to range -1, since we don't want to animate the last blend shape, we break out of the loop. If not, we increase the range index. We can see now that our range is working correctly. Next, to animate the closing, create a coroutine called crack close and lerp all the blend shapes together. Now set the blend shape to the blend shape value multiplied by the 1 minus lerp. This is because we want to lerp to 0. Finally, go through all the cracks and destroy them. Now create a close function and call the coroutine. And call the close function in our update loop on some key press. Now, in our crack prefab, we want to set up some corner points that we'll use later for various effects. Create a container child called corner points, and inside it, create points at each corner of the crack. Next, rotate the points so they face outwards. Now, in our crack script, create a public list of transforms called corner points, and assign all the points to the script. And finally, apply all the changes to the prefab. Now let's create the little side cracks. In our crack control script, create an input bool variable called isSideCrack. Do that also for our coroutine, and pass the variable inside our coroutine. Also, when we call our function in our update loop, set the variable to the false. Now, inside our open coroutine, just below our range index increment, let's create a little segment if it's not a side crack. This is where we'll instantiate the little small cracks. Let's create a random chance to instantiate, and if the chance is great enough, get the corner point that's closest to the blend shape we're currently animating. Next, instantiate this same crack control object inside the container, and set its position to the point position, its transform forward to a random rotation multiplied by the point forward, and set the open value and range to random values. Finally, call the open function with true passed in as a parameter that sets our isSideCrack to true. For each of these numbers, you can create variables at the top of the script so you can control them from the editor. Now, at the top, let's create a new list variable called crackControls. Initialize the list and add all new crack controls to the new list. Now we'll just refactor this segment to a new function. In the close function, go through the list of the crack controls, and for each of them, call the function close. Finally, at the bottom of the crack close function, go through the list and destroy all the crack controls. In the editor, I set the script variables to these values, and we can see our side cracks appearing. Now let's take a look at our slam effect. The first part of this effect is the shockwave. The Shockwave Particle is this circular texture that uses a custom shader graph for the dissolve effect. Back in Unity, let's open up shader graph. We can see I just sampled this texture and multiplied it by the gradient noise, and then I used the vertex color alpha to dissolve the texture. We can see how the dissolve works if we detach the alpha. The shader graph settings are unlit transparent, with the blend mode set to alpha. Now let's quickly take a look at the values of the particle system. You can see the values on the screen. You can tweak these values to see the effects. The only important value is the color over time, so we get our dissolve. Next, let's take a look at these flash lines. As a particle, they use this texture. And for the values, you can also see them on screen. The only important thing is the 3D start size, where if we modify the X and the Y value, we can see the effects. And the 3D start rotation with the X and the Z value set to 90. The shape is also set to a cone with the align to direction activated. Finally, in the renderer, we offset the pivot a little bit, so we get this directional effect. The material uses the regular unlit particle shader, the surface type is set to transparent, the blend mode to additive, the render phase to both, and the emission is activated and set to a yellow color. For these small rocks particles, I use the simple lit particle shader, and in the renderer I set the render mode to the mesh, and set the mesh to this shape. For the values it's all pretty standard, let's take a look. The only interesting thing here is that they have enabled collision, with the plane set to this child object and the bounciness to 0.5. For the crack particle, I use this simple texture and set it to fade in and out. You can create this texture by googling crack ground and just sampling a random portion of the greater texture. And finally, for the smoke particle, it uses the particle unlit shader, but it has the soft particles enabled. We can see the effect here. It also uses the simple texture I created in Photoshop. And finally, let's take a look at the values of the particle system. Now let's parent the slam to our crack control object and open the crack control script. In the script, create a new variable for our slam particle and at the top of the crack open coroutine, if we are not a side crack, we will play the slam particle. It is important for all particle systems in the slam object to have looping disabled and play on awake disabled. Finally, assign the slam object to the crack control script. It's looking good. But if we scale the object a little bit, we can see the effect gets all messed up. To fix this, in our crack open coroutine, where we instantiate our cracks, in addition to multiplying by crack length, we will also multiply by transform.localScale.z value. Now if we scale our object, we can see everything working perfectly. Another effect we will add to the crack system is the small puff. It has two particle systems, the smoke and these little rocks. The particle system is very similar to the previous particle systems. Now let's open up our script and create a new variable called small puff prefab. Then, in our crack open coroutine, in the same place where we instantiate our side cracks, get the crack corner point and instantiate the small puff. Also set its transform forward vector to vector 3 up. In the editor, assign the small puff prefab to the script and press play. Now for the last part of this effect, we have the rock emerge. It consists of three parts: the rock, the ground, and the smoke explosion. For the rock explosion, these are basically the same particle systems as we used in the slam, only a bit modified. For the rock, it uses the simple lit shader. It also uses this custom mesh I created in ZBrush, but you can download some free 3D rock model off the web, and there are plenty tutorials on sculpting rocks. However, for the ground there aren't plenty tutorials, and even though I don't know ZBrush very much, I will show you how I created this. Open up ZBrush, and on the right side in the toolbox select the largest rectangle, and then select Plane 3D. Next, in the same toolbox, click Make Polymesh 3D. Now I use the clay brush to give it a little bit of a bulge. Then in Photoshop I created this texture, blurred it a little bit, and then inverted the colors. Save it, and then in ZBrush, on the left side, click the alpha, and then import the alpha we created. Above the alpha, switch to Draw Rect, then just drag across the geometry. Next, increase the geometry resolution by dividing it. Now in the top left in the brush menu, scroll down to the depth and increase the embed value. Finally, go to the Z plugin menu and scroll down to the decimation master. Pre-process the object and then select Decimate Current. This will reduce the poly count of the object. Finally, on the left side in our toolbox, click Export and export the model to Unity. The ground uses a custom shader so it can blend better with the ground. In the graph settings, the material is lit, the surface is transparent, and the blend is alpha. First, we sampled some texture. This can be a dirt texture, a concrete texture, whatever you wish, and input that in our base color. Then we create this centered mask. We then smooth step it to blend it, and input the result to the alpha. We can see how changing the values of the smooth step affects the object. This is so it can blend seamlessly with the ground. Next, I created these two animations for the rock object. One for the emerging, and the one for going down and disappearing. At the end of the disappearing animation, we call the animation event, which simply deactivates the object. Now parent our rock object to our crack control and deactivate it. Now in our script, create an animator variable and call it a rock emerge. Then in our crack open coroutine, at the very bottom, check if you're not a side crack, then activate the object and set its position to the end of the crack. And finally call the animator trigger appear. For the closing, at the top of the crack close coroutine, just call the rock emerge set trigger disappear. Now let's take a look at the animator and how the animations are set up. We only have two triggers, appear and disappear. Finally, we'll add the animator reference to our script, and let's see the effect in action. That is it, the effect is finished. I know some improvements can be made, but I wanted to keep it as simple as possible. Thank you for watching this video, I hope you liked this Earth Slam effect. The link to the Git project will be in the description, and if you liked the video, please like and subscribe, and I'll see you next time.